Section 2.1, the tangent and the velocity problem. First thing to recall, what is a tangent? So tangent here, what we mean by tangent, so if you have a curve like this, it's just the line that touches the curve at exactly one point. That's a tangent, and this point I is called point of tangency. So this is a tangent line. In trig, yes, it is sine over cosine. If it goes through more than one point like this, then it's called a secant line. So the question we're going to use here, or try to find here, how to use calculus to find, so to answer one question, how to find the equation of a tangent line. That's what we're going to be finding now. And to do so, we need to recall some basic concepts from before. When we talk about tangent lines, we mean straight lines. The first one is y equals mx plus b, slope-intercept form, or y minus y1 equals m times x minus x1, point-slope form. So this is slope-intercept form. And this is point-slope form. So the first one, to find the equation of the first line, you need a slope and y-intercept. To find the equation of the second one, you need a point and a slope. So how do we do this? Let's look at, take a function, y equals x squared. This is the graph y equals x squared. Let's say we are asked to find what is the equation of the tangent line to the graph of y equals x squared at point t, say t11. So say this is 1, 1. There's a tangent line here. I'm going to draw it with the green color. Tangent line. This is point T. To do so, what we need to do is to find that line or equation of that line. We pick any point here, R, on the graph. So choose or pick a point R with coordinates x, y. You can write it as x comma y is x squared. So this point R has coordinates x comma x squared. And what we're going to do is we are going to connect R with T. That'll give me a secant line. So connect R to T. So now R and T is a secant line. So what we do is we find the slope of RT, which is the secant line. How do you find the slope? It's y2 minus y1 over x2 minus x1. y2 is x squared. y1 is 1, x minus 1. X minus 1, x plus 1 over x minus 1. These cancel, so I got x plus 1. Right, that's the slope of the secant line. Like, but it's, if you notice, it's in terms of x. It's not a number. We would like to know the slope of the secant line because I have the point. I just need the slope. So now, what we have here is that we found out the slope of RT in terms of x. What am I going to do with this? I'm interested to find the equation of tangent line. So I do know the point 1, 1. I just want to find the slope of that tangent line. How do I find the slope tangent line? Well, this is an x, right? This is x here. What I'm going to do with this x, I'm going to approach this 1 from both sides, from this side of 1 and from this side of 1. And let's see what happens. And how do I do so? We can create a table of values for x and get the value of the slope that corresponds to that to that x value. So let me put 1 in the middle. I'm interested to find the slope at x equals 1. To do that, I'm going to pick 1.00001, 1.001, 1.1, 1.5, 0.999, 0.9, and 0.6. What do we get here? This is 2 point, if you substitute in there, 0.0001, 2.001, 2.1, 2.5. 1.999, 1.9, 1.6, if you substitute them in. So notice what's happening. If we approach it this way and that way, these values are growing from the left side to some value, and the top or the bottom, the ones on the right side are approaching another value. What is that value? They are approaching what? Approaching 2, right? So we can say that the slope of the tangent line, m means slope, is 2 at the point 1, 1. So we found the slope, and then we can use y minus y1 because I have a slope and a point, x minus x1. So y minus y1 is 1, slope is 2, x minus x1 is 1. Then we are going to multiply the 2 in, 2x minus 2. Add 1 to both sides, 2x minus 1. This is the equation of the tangent line from to the graph of y equals x squared at the point 1, 1. Notice what happens here. If you move r down, like put it here, and then here, and then here, as r moves down, the black line gets closer and closer to the green line. So the black line will become a tangent line at some point. Do you see what happens? Next one. Now recall from physics, s of t is called the position function. Position function at time t, and we'll come back to that tangent line later today. V of t is the velocity function at time t. Then the average velocity, we define the average velocity is the distance over time, right? We know distance over time. And when we say distance here, we mean the change in the position. That gives you the distance over change in time. So what happened is, say you have a car moving from one place to another. So the car was here at time equals t1. The car then became here at time equals t2. So if we would like to find the change in the position, that would be when is it going to be at time 2 minus when is it going to be at time 1. Assume it starts somewhere here. The difference in the position from here to there is basically you take the whole thing minus this over the change in time, that's t2 minus t1. What is this? This looks like a slope formula, y2 minus y1 over x2 minus x1. So that tells me, what does that equal to, or what does it tell us? This tells us that the average velocity equals what? So the average velocity, from here we can say that the average velocity is the slope of the secant line. That's what the average velocity is the slope of the secant line. Example. Let's look at an example. If s of t given to us as 9.8 over 2t squared, or 4.9 t squared. Find the average velocity over the interval 5, 5.1. How are we going to find the average velocity? Well, we define the average velocity to be s of t2 minus s of t1 over t2 minus t1. So this is t1, this is t2. So we can find it by finding s of 5.5, that's t2, minus s of 5 over 5.5 minus 5. How do I find s of 5.5? All you have to do is just substitute into the given formula. 4.9 times 5.5 square minus 4.9 times 5 square over 0.5. Can I change the number instead of 5.5? Can I make it 5.1? 5.1, 5.1, 5.1. That gives us 0.1. So I change 5.5 to 5.1. And I'm putting that on the calculator. Let's see what that's going to give us. That gave me 49.49 meters per second. If you try to run over different intervals, the first interval I gave you now, it was 5 to 5.1. What about if we take over different intervals? So here, let's say the interval, and here that will give me the average velocity. The first interval, I'm going to pick 4.99 to 5. 5 to 5.1. 5 to 5.6. 5 to 6. The only one we found is 5 to 5.1, and we got 49.49 meters per second. I did the first one on my own. I got 48.95 meters per second. I did the next one, the third one, I got 51.94 meters per second. And I did the last one, 53.9 meters per second. Okay, now the next thing we need to find out is how about finding the velocity after exactly, let's say, 5 seconds. So we have been finding the average velocity over a specific interval. But here, what about if we need to find exactly at 5 seconds? How do we do so? Well, we can look at all these intervals that we got earlier. You see some of them a little bit below 5, some over the 5, some above 5. what can be a good guess here that we can conclude, for example, like if we look at these two, these are the ones that are closest to 5 or over 5. What can be here? What can be the velocity after exactly 5 seconds? What can be a good guess? If you look at the first one, 4.99 to 5, over that interval was 48.95. When we went a little bit above 5 to 5.1, it was 49.49. We can guess and say from the above table, or table above, we can say the velocity is 49 meters per second at 5 seconds. And since it was exactly at that minute, at that time, 5 seconds, we say this is called instantaneous velocity. Instantaneous velocity. The first one was average velocity. This is instantaneous velocity. And we can conclude the following. We can say then the slope of the tangent line is the instantaneous velocity. So two things. One, the slope of the secant line, is the average velocity. The slope of the secant of the tangent line is the instantaneous velocity, because you're calculating it exactly at that minute, at that instant, when t equals 5 seconds. That's what we call instantaneous velocity. Any questions about this? So it's a very short section. The idea behind it is to get you to learn two things. One, the average velocity over a specific interval is the slope of the secant line. And the slope of the tangent line at some point is the instantaneous velocity. That's all they want us to learn in this section. And it's a good review to learn how to, or recall how to find equations of straight lines and how to calculate the slope for two given points, or for the line connecting two given points. Any questions about this?